Hello and welcome to another free code session. My name is Jason Bach and I have improvements. I have some improvements. So this is the 3 runs that I did. This is with 7.3.0 and then the first alpha, and then I released the second alpha. And I'll describe what I did in that in just a moment. I kind of showed that in the last episode, but these are the results. And it was, again, just easier to do this work off camera because most of it was actually not that hard. But it was a fair amount of time just going through and updating all the tests because they all broke. And you'll see why in a moment. So it's not worth doing an episode on that because all I would do is be like, I'll be right back. And then, hey, they all passed. And you don't want to see all these tests being changed. That would be boring. So I undid the little bit of damage that I did. Again, things got faster anyway, but now they're really good. And with the construction one, again, it's what the ratio is like 4. It used to be 3, but we're talking like literally 20, 70 nanoseconds, whatever it is. It's like nothing. The thing to notice though is that I did 144 bytes. I then upped it to 280, but now I'm back down to 128. I don't know why the coloring in VS Code likes this version better than the other ones. Like it colorizes it for some reason. I don't know why, but it does. With other things, it got better too. If you look at let's pick one parameter just because. And if I go to the 7.3 version, I'll get that up here. That was ratio of 24 and 33. When I did the first alpha, that went to, if I could actually move correctly, 17 and 21. So, I mean, it already got better. But now it's even that much better. It's 13 and 15. We went from, even with the alpha, which the first one, which is faster, from 283 to 271. Not that big of an improvement, but somewhat. But then the memory went from 504 bytes to 376. So, it makes all these little improvements are making things better and better. The other one was the verify. That got worse, but now that's better again. So we were at 35 and 31. It went up to 54 and 73. And now we're at 22 and 24. Yeah, 22 and 24. Which is better than what we have in 7.3. So that got better too. So very, very happy. Yesterday I was telling the family, if you ever want just for me to give you something, let me know because I'm in a very good mood. I was yesterday. I was in a very good mood. And I told my wife, it's very satisfying to put in a lot of work and to actually see the results of it, to see that all that hard work that you did was worth it. And to me, this is worth it. It may not be worth it to anybody else, and who knows if anybody actually uses this, but to me, it's worth it. I've learned a ton. I'm happy that I put all this work into it and that I can actually show results to say, yes, it is the fastest out there. It consumes the least amount of memory. The numbers speak for themselves. Now, of course, there's always how much time does it actually take to build? And that is something that I'm looking at as a post 8 release, is to spend more time in a profiler, spending more time looking at what kind of optimizations I can make on the actual construction of the mock. I think it's on the order of microseconds. I don't remember how much of that is, but it's pretty quick. But again, I want hard numbers. I know I can come to this and say, this is how long it takes to actually create the mock. So I want to see if I can hit those numbers down, get the speed better, get the memory allocation better. That's on the roadmap. But for now, the numbers that I've seen before in just some quick perf tests, it seems like it's okay-ish. It doesn't stick out. Now it does when you load rocks, because there's so many mocks that are being created in integration tests. And that's actually very unusual. You wouldn't usually have a project that has probably tens, if not hundreds, of mocks. You probably only have 5, maybe 10 At least that's what I've typically seen. So in any event, that's on the roadmap, but I'm happy for this now. The goal has been achieved, definitely. So that's good. So what did I do? Again, I'm just going to grab one of these outputs. It really doesn't matter which one because it all shows the same. First thing is I made all these fields now not read-only because they can be changed later on, but they're nullable. So we don't allocate right away. I also put a check around calling verify unless something has actually been set in the list. I think I just said array before. Maybe I didn't. I don't remember. But it is a list. It's an array underneath the scenes, but you get what I'm saying. All the checks here for the handler implementations for the members, they now have nullable checks around stuff. So before they do count, they'll make sure that the list has actually been set. And then way down at the bottom here, I will make a check first to see if it's null, and if it is, then I create a new list. This is one thing I thought of today is there is a way to pass in an enumerable to a list to say, set it to this. And that is something I'm going to look at because most people would only create a mock where an expectation for a particular member is only being set once. So what I'm wondering is, could I allocate it to one right away? Is it better to set the capacity to one and then allocate? Is it better to pass in an enumerable using a collection expression and pass that in? Because you gotta add something in. So why don't you do it when you knew it up? That's probably a very small micro optimization, but that is something I'm going to look at to say, could I do that? And then these would change. Okay. One thing you're also seeing here too is another change I made this morning is I noticed that it was possible that you could create the mock and then set expectations after you created the mock, but before you called verify. And that's not something I wanted to allow because my mentality around mock usage is you create your expectations, you pass the mock into your code under test and run it, and then you verify it. And it feels like if you have that in, even though I didn't say that you could, because I don't even remember if you could do that before. I know you could do that now. I realized that last night. I'm like, oh yeah, you could actually do that. And I verified that with the test this morning. So what I added is a check to say if an expectation object was instance invoked, which means that you created a mock, then throw an exception because you should not be allowed to do that. And people may disagree with that. I personally think that the order should stick. You should know your expectations and not dynamically start creating them after your mock is starting to be used. That feels very weird to me. So it's also what just went through my head is it's the mindset of release something in a more strict way, a more locked down way until you have justification for allowing flexibility to be more open. And some people, they don't get that. Like, why do I seal classes? I seal them in part because it's a tiny bit better in terms of performance, but that's not really it. It's more of a design philosophy, which is unless you're designing for your class or your type to be inherited, then don't seal it. Because if you allow people to derive from it, inheritance is a very strong form of coupling, arguably the strongest. And you may not know how somebody's actually going to use your members in a subclass. So unless you're designing for that, don't do it. So I always seal my classes, and if somebody goes, hey, I've got a situation where we need to have polymorphic capabilities, we need to do something like that, okay, then that makes sense. But unless the design calls for it, just seal it. And this is kind of the same thing. Don't allow this unless somebody comes up with a really, really good reason or rationale why I should, and then I just take these out. So that's the work I've done now. I've got an Alpha 2 out there. By the time you see this video, I probably will have released the 8.0.0 version. I have Transpire up here because we're going to do some analyzers for a second, not in Transpire, but in rocks. But if I look at my list here, I am probably going to move this artifacts thing out because I tried that in the previous episode and it really screwed things up. I don't know why. So I'm like, no, we're going to just not even deal with that. This is the one I'm going to work on right now. The open generics is definitely a valuable one, but I'll probably do that as an 8.1 release because I just want to get this out the door right now. And those are and then the benchmark mocknet I'm just doing. So really the last thing I want to do is this diagnostic to analyzers. And that should be it. Oh, there was one other thing I noticed with extremely rare name collisions. One other one is the expectations property. There is, where is this? When you pass it into the mock, it sets it here. It's possible that the mock could have a property called expectations that it's going to define because the interface has something called expectations, and then you'd have problems. So what I'm going to do is make this a read-only property, field that is set. Interfaces can't define fields, so if your mock type is a field, it wouldn't have one anyway. If it's a class, it might. And then what I would do is I would just say, okay, for all of the fields that are there, then if there is one called expectations, which it really shouldn't, but if there is one there, then just do the thing with the variable naming context to make sure I find one that is. And then that's what you're going to use all throughout the mock type is that. So it's a small thing, but again, these very rare cases are cases that at some point may come up and I can easily handle them. So, but again, I'll do that in a future release. All right, analyzers. So this may take a couple of episodes, but let's go back over here and let's bring this one up. Again, this is the generator shouldn't be capturing the diagnostics. More to the point, it should not be passing them into the callback from register source output and setting the diagnostics there, because then you technically can never really have the read-only model that you want. So what I want to do is basically two things. If I come back up here and I go into something like rock create attribute, no, I'm not the attribute, the generator here. So in here, this is going to change slightly. I got to pass a list out, but I'm still going to do something where, if the type itself has diagnostics, I don't do anything with it. But I'm going to create the mock model, and then I'm going to see, where is this? This whole thing gets added to models because it's a mock model. Okay, so this is going to take a little bit of adjustment. In the create here, what comes out of a mock model is diagnostics, and we have to remove that to a certain degree. What I really want to do is grab this, but then have where I just return the build type, the fully qualified name, and the type. I don't return the diagnostics. I'll use them here and say, well, if there were any diagnostics, like here, or that really, if the type was null, which I think is what happens within, yeah, I look at the mockable thing and then I do that. So what I'm going to do is change this so that this produces a tuple or some other record that is just like mock model information. That's what actually comes out of this if there's no diagnostics. So a little bit of a change, but that should then just flow through everything here. I would no longer report diagnostics, and this is kind of a useless check because I don't think I can get to this point with the type being null, but it's like a double check that's pretty worthless. I probably can remove that, but that's not the point. This is what would go away, and that would no longer trickle through. And of course, if I make this record type, that's going to change some things internally, but it's going to be pretty minor because really what happens is when you get to, right here, rock create builders, you're passing in the type. That's what matters at that point. You don't even really care. Well, you care about the mock here, your diagnostics would go away. You care about the type, the build name, and then I think that's type, build name, and I think builder.name actually comes out from, but it doesn't because it only has the type here. So I'm not really sure at this point if I look at what comes out of mock model. We have build type, fully qualified name, and type. What is fully qualified name used for? I wonder if that's being used to come up with the file name. I think that's why I passed that along. I'm not really sure. It's only being used here, so I think I think I can get rid of the FQN here. Doesn't seem to be used. Oh, I should have not. Doesn't seem to be used anymore. I don't think. If I come back over here and I go into rock create builder, because it's getting just a type mock model, it doesn't use that. So where does it actually get the file name? Mock type, fully qualified name, generate. So we get it from there. Yeah, we don't even use that anymore. So really all we need to return is the build type and the type. That's it. So that's just one half of the equation here, though. The other one is I need to actually do the same thing. I need to, in a sense, except from another angle, I need to create an analyzer that is going to look for the attribute. How I do this, I'm not sure. I think I'm going to look for constructors. And because when you actually define an attribute, you're defining a constructor and then look to see if the parent, to see if that constructor is actually the constructor on rock attribute. Actually, no, rock create or rock mate. Either one, it doesn't matter. If it's one of those, then what we do is we look within the generic parameter, which is what we're doing up here somewhere. Yeah, we get the attribute class, the context. This gives you the attribute class, but what I would do is I would say I know that this is I know that this constructor is from these two attributes, so therefore its containing type would be one of the two, one or the other, and then I would go look at its attribute data. I forget exactly how that works, but that's the way it works. Okay, attributes here, their attribute data. So the point is that I'd basically get to the attributes, then I could get the type to mock. This is just a type symbol. And then I pass it in here too. I could also do this check as well. I keep the diagnostics on the mock model here. That's something that I got to be really careful of, is the mock model will probably have two things on it. It will have the diagnostics and it will have information being this record where it will contain the build type and the type, no longer the FQN. And then in here, we use it, as I just mentioned. In the analyzer, we would just use it to find if diagnostics need to be reported, and then it would do essentially this. So it's just a reshuffling. So let's get to it. Enough talk, Jason. Let's actually get to this. So when in doubt, copy code, right? Let's just copy code. I have one that does something for analyzers, specifically for constructors. So I'm kind of thinking, let's just these are the tests. We're going to have to pull some test stuff in as well, but let's actually get the analyzer in place first. If I do raw, we'll just do that, and then we'll tweak as necessary. So we'll come into here. What do we want to call this? Naming is hard, right? Naming is hard. Rock analyzer. Sure, why not? Rock analyzer. Now for the main project, there really should be no need to pull anything else in. I think there's also another test assembly we want to bring in as well, but that's okay. So if I remember right, this can be, we want it to be, well, let's just do that, and then we'll come back up here and we'll start tweaking things as needed. That comes up there. This goes down here. We don't need that. This is rock analyzer, which is that. Diagnostics description rule. How do we, do we really need that? The thing that I'm wondering is supported diagnostics. So if I say descriptor here, Where is the descriptor? This might take a little bit of change. These are all the descriptors. So this is a find daytime. So this gives you a diagnostic descriptor like that. And I believe if I come back up here, this takes a create. This is the diagnostic descriptor. So I don't have these in place right now. I don't separate them. You know what I mean? And I'm not sure that this was something I kind of forgot. You need the descriptors to say which analyzer can be, what rules can you support? And that makes sense because you want to be able through all the infrastructure to do that. What I might have to do is, again, some changing here. So for example, it's buried in here. The create takes it. So it takes a diagnostic descriptor, but then there's also the location. What we are doing within the new is, I think we are taking the location here. Yes. We get the help link, the string format, which is the culture, and it's obsolete and cannot be mocked. So what we need to do is change this so that I'm babbling a little bit. Here you see that I have diagnostic create. I'm passing in the descriptor, and then I get the location. So we have to break this up a little bit. So how do I want to do this? What would be the right way to do this? I have to be able to report supported diagnostics. Returns a set of descriptors for the diagnostics that this analyzer is capable of producing. Part of me just wants to be lazy and go, no, I don't want to return anything. Guess what I'm going to do? But I don't think you can do that. I'm not sure if it's enforced if you don't return anything from this, but then you say, oh yeah, I created a diagnostic later. But I think the right thing to do in this case would be have our rules in place, our descriptors, and then these diagnostics actually would change because we don't need to necessarily keep them as diagnostics. I've done that because it's easier for what I'm doing right now, but yeah, this is going to have to change. So let's make some notes here because notes are good, right? So need to change the diagnostics so that they're descriptors and then report all of those from our analyzer. I mean, that's the first thing I'm going to need to do. So I think what I'm going to do is, I don't want to move too far on this, but I'm going to just tweak these so that they're changed to be descriptors. We also want to be careful because we keep the format here. I don't know if in Rock Analyzer with what we did here, we are passing in the location here. I'm not sure in Transpire if I had a case where I wanted to have something specified in the message, so that it's formatted. I think all of these oh yes, here. Okay, so method generic parameter count error description. So method generic description. So yeah, here I have all the diagnostics, and you can see here I don't actually have a read-only property, I don't think. Yeah. So I just report these, the default values, and then down here create. Yeah, and then I think the descriptor for this is assuming that you're passing in a parameter for that. So if I come back here, we go down here and we create it, we say from the descriptor create, we pass in one of the values, and then that gets a descriptor, but then for the diagnostic, that's where we pass in the location because that's no longer part of the descriptor. So that's going to take some refactoring work. I'll do that off camera, but I'll stop there even if things don't compile because I want to keep going on with building the analyzer and doing it in the video because this change doesn't require, there's some tests that are going to break, but really from the perspective of the user and the mock code that's created, none of that changes. This is purely just kind of an infrastructure change to say how errors are reported. So that's what I'm going to do in the next episode. Thank you all for watching. Leave comments and questions below. See you in the next episode.